In this video we will discuss about flow and its types. Flow. A material goes under deformation when different forces act upon it. If the deformation continuously increases without limit, then the phenomenon is known as flow. Types of flows. When a fluid is flowing in a channel, numerous small particles get together and form the flowing stream. Themselves in a while moving, group EOG in a variety of ways. They may move in regular formation, just as disciplined soldiers do, or they may be a disorderly mob. The type of flow of a fluid depends upon the manner in which the particles unite and move through. There are many types of flows. The following are some important ones. Uniform flow. A flow in which the velocity of liquid particles at all sections of the pipe or the channel are equal. This term is generally applied to flow in channels. Non-uniform flow. A flow in which the velocity of liquid particles at all sections of the pipe or the channel are not equal. Laminar flow. A flow in which each liquid particle has a definite and the paths of individual particles do not cross each other. Turbulent flow. A flow in which each liquid particle does not have a definite path and the paths of individual particles also cross each other. Steady flow. A flow in which the quantity of liquid flowing per second is constant or if properties at each point in a flow field do not change with time. The flow is termed steadily. Unsteady flow. A flow in which the quantity of liquid flowing per second is not constant. Incompressible flow. A flow in which the volume and thus the density of flowing fluid does not change during the flow. All the liquids are generally considered to have incompressible flow. Rotational flow. A flow in which the fluid particles also rotate, i.e., have the same angular velocity about their own axes while flowing. In a rotational flow, if a matchstick is thrown on the surface of the moving fluid, it will rotate about its axis. Irrational flow, in which the fluid particles do not rotate about their own axes, and retain their own original orientation. In an irrotational flow, if matchstick is thrown on the surface of the moving fluid, it does not rotate about its axis but retains its original orientation. One-dimensional flow. A flow whose streamlines may be represented by a straight line. It is because of the reason that straight streamlines, being a mathematical lines, possess one-dimensional only one either XX, YY, or ZZ direction. Two-dimensional flow. A flow whose streamlines may be represented by a curve. It is because of the reason that a curved streamline will be along any two mutually perpendicular directions.